So chapter 3, differentiation rules, talking about the derivatives of polynomials and exponential functions. This will be our first step toward finding derivatives without having to do the work with limits. We're going to use that idea to find some shortcuts, if you will. So if we want to take the derivative of a constant function, again, the idea being we have f prime of x would be the limit as h approaches 0 of f of x plus h minus f of x all divided by h. For the constant function, there is no x. So this would be f of x plus h is just c, and f of x is c all over h. This would be the limit as h approaches 0 of 0 over h, which is 0. Doesn't matter what h approaches. 0 divided by h is 0. So the derivative of a constant function is 0. So we're actually going to take the next step and find the derivative of x. So that would be the limit as h approaches 0 of f of x plus h minus f of x all divided by h. Limit as h approaches 0. So f of x plus h is just x plus h. F of x is x, all divided by h. X minus x, they cancel out. We would have h over h, which is 1. So the derivative of x is 1. So now let's take a look what happens when we take the derivative of x squared. So again, f prime of x would be the limit as h approaches 0 of f of x plus h minus f of x all divided by h. So we would have the limit as h approaches 0 of x plus h squared minus x squared all over h. So here we're going to take the limit as h approaches 0. X plus h squared is x squared plus 2xh plus h squared minus x squared all over h, just multiplying out that binomial squared. And if we combine our like terms, x squared minus x squared, they cancel out. Leaves us with 2xh plus h squared all over h. Factor out an h. 2x plus h over h. H's cancel out. As h approaches 0, that goes to 2x. So the derivative of x squared is 2x. Now, hopefully, you're seeing a little pattern here. The derivative of x squared is 2x. The derivative of x is 1. The derivative of a constant is 0. The derivative of x cubed would be 3x squared. The derivative of x to the fourth would be 4x to the third. And hopefully, again, you can see there's a pattern there. And the pattern goes like this. For x to any power n, its derivative, you take that power, bring it down, put it in front as a coefficient, and you take x to one less power. So x to the n, its derivative is n times x to the n minus 1. A couple of other rules as we go through derivatives. If we have a constant times a function, the derivative of a constant times a function f of x, you can take that constant and kind of remove it. And so you take the constant times the derivative of f of x. So whatever the derivative of f of x is, you multiply it by that constant. The sum rule, if we have functions f and g, and they're both differentiable, we can take their derivatives. Then the derivative of the sum of those two functions is the derivative of the first function plus the derivative of the second. So the derivative of the sum is equal to the sum of the derivatives. Very useful when we work with polynomials. Again, if f and g are both differentiable, then the derivative of the difference of the two functions is the derivative of the first minus the derivative of the second. The derivative of the difference is the difference of the two derivatives. So let's try take this derivative. The derivative of x to the eighth plus 12x to the fifth minus 4x to the fourth plus 10x to the third minus 6x plus 5. A rule for a power function, take the exponent, bring it down, take our variable to one less power. Here we take that 12, pull it out, just ignore it for a minute. X to the fifth power would be 5 times x to the fourth. Ignore the 4 in front of the x to the fourth. The derivative of x to the fourth is 4x to the third. Ignore the 10. X cubed would be 3x squared. Ignore the 6. The derivative of x would be 1. And the derivative of the 5, that constant, is 0. Now let's simplify that expression. 8x to the seventh plus 60x to the fourth minus 16x cubed plus 30x squared minus 6. There is that derivative. Much better than taking the limit as h approaches 0 of f of x plus h minus f of x all divided by h. The last function we're going to talk about today, the exponential function. The definition of the number e, one of our great irrational numbers in mathematics. E is a number such that the limit as h approaches 0 of e to the h minus 1 all divided by h is equal to 1. What does that mean for us? Well, that means that the derivative of e to the x is e to the x. One of the easiest derivatives in all of mathematics. So if f of x is e to the x minus x, find f prime and f double prime. So for f prime of x, we can use that derivative of a difference. We take the derivative of each piece. The derivative of e to the x is e to the x. The derivative of x is 1. Then for the second derivative, we take the derivative of our result here. Derivative of e to the x is e to the x. Derivative of 1 is 0. So there is the second derivative and the first derivative. Last thing I want to talk about this wonderful, what if we have f of x equals x squared plus 4x plus 3 divided by x to the 1/2. At this point, we don't have a rule to take the derivative of a quotient. So if we only have a single function in the denominator, what we're going to do is rewrite our function so that we divide each term by the denominator, which we can do because that's just the definition of the addition of fractions. If I simplify this expression, this is still my function f of x. X to the 1/2, x squared divided by x to the 1/2. Subtract our exponents. This would give me x to the 1/2. I'm sorry, that would give me x to the 3/2. 4x divided by x to the 1/2 would be 4x to the 1/2. And 3 divided by x to the 1/2, I'm going to use what I know about dividing by a fraction, that x to the 1/2 in the denominator is exactly the same as x to the negative 1/2. And get used to seeing that using negative exponents and fractional exponents throughout those throughout the year as we work on functions. Now take the derivative. Take my power, bring it down. Take x to 1 less power. Take the power, bring it down. Take x to 1 less power. Take the power, bring it down. Take x to 1 less power. So we would get 3/2, x to the 1/2. Taking 4 times 1/2, that's 2, x to the negative 1/2. Minus 3/2, x to the negative 3/2. There is our derivative. All right, for your assignment. On page 181 and 182, please take care of problems 4 through 20, the evens, and problems 29, 30, 41, and 42. See you back in class. Have a wonderful day.